Welcome all back to another exciting adventure. So in 8.2, we were talking about the Pythagorean theorem. We spoke about the Pythagorean theorem before already, but we're going to speak more about the converse of it. Now, remember, converse is when you repeat the same thing but kind of backwards as we'll go through this. So this again is Pythagoras. He's one of the main dudes that created the Pythagorean theorem. He is the main dude. But not only that, he was also a philosopher, which back in the day, what else you got to do except sit around, do some math, and think about life. That's what he did. Again, like I say, he actually kind of created his own spiritual movement called the Pythagoreanism. But these are other little famous quotes. You don't have to write this down. These are just things that I think are pretty enlightening. But let's kind of go to the theorem itself. So, as the theorem states, in the right triangle, the square of the hypotenuse is equal to the sum of the squares of the legs. So let's kind of define some of these things. Let's start with C, the hypotenuse. Again, it states that it's a right triangle, so we know there's a right angle right here. Nice little right angle. Now, across from that right angle will always be the hypotenuse, which is the longest side. So we call that the hypotenuse. The other two sides are just considered legs. So the two smaller of the three sides are legs, A and B. It doesn't matter which one you call A, which one you call B, it's just A and B. Okay, so A squared, so the value of A, we squared, plus the value of B squared equals C squared. Capiche? Capiche. So let's kind of try those out right here. So throughout the home, we're going to have some missing sides. So for example, on here, let's kind of denounce where our right angles are at. Right angle right there, right there, right there, right there. So what matters the most is what is C? What is our hypotenuse? So on this first one, 13 right here is our C. So this is our hypotenuse. So as we set this up, we can call this A, we can call this B. Those two doesn't necessarily matter which one you call which. But as we set it up to solve, we'll say, hey, 5 squared, which are A, plus our B squared equals 13 squared. Now we square those numbers, not times 2, it's not 5 times 2, it's 5 times 5. We get 25 plus B squared equal 169. Now to solve for B squared, we will then subtract 25, giving us B squared equals 144. Now, like we've been doing before, to get rid of the square on a variable, we square root, which one side to the other side. So we're left with just B equals 12. So the value of this side is 12. All right, let's kind of try this another one. This time we're looking again, here's our right angle, there's our hypotenuse, that means this is our C. That's what we're looking for this time. So A, B, we set it up as 4 squared plus 3 squared equals C squared. 4 squared is again 16. 3 squared is 9. That gives us C squared. We add those two up, we get 25 equals C squared. So again, just to get C, square root both sides. 5 equal C. And we can see the same thing. So we got A right here, B right here. So we're looking for B. A right here, B right here. We're looking for B again. Try them out one more time. So I'll set them up, but then you guys will finish them. So as we set this up, we'll say, hey, 8 squared plus B squared equals 17 squared. On this one, that's when you set it up, you do 12 squared plus B squared equals 15 squared. Hopefully you did them in class and you know them all by now, the answers. But let's kind of move on. Just look at the more impeding things to talk about. So Pythagorean triples are a set of numbers in the form of A, B, and C, so A, B, and C, in which they give you their perfect numbers. So they give you whole numbers. So actually, let's go back and do one. Let's look at this one right here. So if we were to take 17 squared, 17 times 17, let me get my calculator out. 17 times 17, you get 281, or 89, sorry. 6 squared is 64. So 64 plus B squared equals that. So we subtract 64 from both sides. B squared equals 225. So that's the square root. B equals 15. And this one is 13, I think. 225, 144 plus b squared minus 144 is 81. So this one works out. So equals 81. So b equals 9. So let's pick something else. Oh, let's look at the isosceles triangle that has a value of 1 and 1. The right triangle. Let's find c. So we're going to do this. We'll do 1 squared plus 1 squared equals c squared. So you get 1 plus 1 equals c squared. Add them up, you get 2. 2 equals c squared. You square root that. You cannot square root a 2, so it stays as radical 2 equals c. So that means this Pythagorean order is 1, 1, radical 2. This is not a perfect Pythagorean triple. If you look at all these, there's not a single radicals. Now, these are just the most common sets that you might see throughout. As you go through this, part of the homework is going to ask you, hey, are these numbers Pythagorean triples? Well, what you're going to do is you're going to take the first two. So, for example, 3 and 4. Take 3 squared plus 4 squared will equal the value of the biggest number, should equal the value of the big number, 5 squared. So you get 9 plus 16 equals 25. So 25 equals 25. So yes, this is a Pythagorean triple. So these are all perfect square numbers, not perfect squares, but perfect solid whole numbers that are all will always equal. The first two square will always equal the last one square. So throughout the homework, when they talk to you about Pythagorean triples, this is what they're talking about. Let's look at the other part. Now there's a whole lot of stuff going on right here, okay? But don't overthink it. So the converse of the Pythagorean triple. So the Pythagorean theorem is if you have a right triangle, then the square of the hypotenuse is equal to the sum of the square of the legs. Now the converse is the opposite. We don't know it's a right triangle. Okay, but we're going to test it out. To test it out, we'll say, okay, we're going to take the value of the two smaller legs, the two other sides, and we square those, so should equal the value of the longest leg squared as well. So that's what we're doing. Okay, that's why it's written kind of backwards to show that, hey, the longest leg square should equal the other two legs added together, the sum of those two squares. Now, for this theorem, let's say we try that out. We tried that out and it didn't work out. The value of our hypotenuse squared was smaller than the value of a squared plus b squared, or the two smaller legs squared. If that happens, then that tells us that's an acute triangle. That means, again, acute triangle is when all three angles are less than 90 degrees. If we do that, if we try to do a Pythagorean theorem, but we find that the value of our longest leg is bigger, so greater than the sum of the squares of the two smaller legs, then that's an obtuse triangle. Okay, so if the hypotenuse is bigger, it's obtuse. If the hypotenuse is smaller, it's an acute. Let's try those out. So the goal is to see, are these right, acute, or obtuse? So in 4, 4 radical 3, and 8, 8 will be assumed to be our hypotenuse. So we're going to say, hey, 8 squared equals, and I'll put a question mark above it because we don't know, but we're going to assume equals 4 squared plus 4 radical 3 squared. Okay, so we do that. Let me scoot this over. Let's have room. There we go. So we square 8, we get 64. 4 squared, again, is 16. Now, when squaring something has a radical, you square the 4 and then 3 individually. So when you do so, you get 16 times radical 9. Okay, because you square the 3 under the radical. And then the square root of that becomes a 3. So let's take 3 times 16, because it's 30, 48. We add those up, we get 64 equals 64. So since the hypotenuse, the longest leg, is equal to the sum of the two, this is a right triangle. That's how you test if it is. Let's look at 4, 6, and 8. So 4, 6, and 8, we're assuming again 8 is the hypotenuse. So 8 equals question mark, 4 squared plus 6 squared. Well, let's try this out again. 8 squared is 64. 4 squared is 16. 6 squared is 36. So we still have 64 over here. But if we add these two up, we get 30, 40, 52. Okay, the value of our hypotenuse is greater than the value of our two other legs together. And like we said earlier, if your hypotenuse is greater than the other two, it's an obtuse. So these are the three sides to a triangle. When we did this, we found out that the hypotenuse is bigger. So this is an obtuse triangle. Now let's look at this one. All right, so 12 can be assumed to be our hypotenuse. So 12 squared equals maybe 8 squared plus 10 squared. So 12 squared again is 144. 8 squared is 64. And 10 squared is 100. We add those up, we get 164. And 144 is smaller than that. So the hypotenuse is smaller than the sum of the other two. So it says up here, if the hypotenuse is less than a squared plus b squared, that's an acute triangle. Acute triangle. So the other part of your homework was to determine, is this a right, obtuse, or acute triangles? Always assume the biggest number, usually the third number they give you, is the hypotenuse. Okay? Y'all have a wonderful day.